Okay, so now I will be going over question 19. So the first important concept in question 19 is moment of inertia. Okay, so the definition of moment of inertia is a quantity expressing a body's tendency to resist angular acceleration. So basically, moment of inertia is rotational inertia. I am going to give the formula for moment of inertia. So we say I, which is moment of inertia, is equal to m, so mass times r squared. R is the radius. So I equals mr squared is the formula for moment of inertia. Okay, so basically the moment of inertia of any object about an axis through its is at a minimum when it's at its center of mass. So when it's rotating at its center of mass, it is at a minimum, and that is because, as you can see from this, the radius will be the smallest it can be. So the moment of inertia will be at its minimum value when the axis of rotation is at its center of mass. Okay, so that's just an important concept. So the next concept I am going to go over is the parallel axis theorem. Okay, so basically the parallel axis theorem says moment of inertia about any axis parallel to that axis through the center of mass, and that is parallel axis theorem. So I'm going to write the equation. So the new moment of inertia is equal to the old moment of inertia, so the initial moment of inertia, plus m, the mass, times the distance squared. And I'm just going to draw a picture of that. So let's say we're rotating this disc right here. So this is our old moment of inertia, and we're rotating it around the center of mass here. And then our new moment of inertia, we're going to be rotating it on the edge. So this is the I new, and this is the distance. So basically, in this formula, we can determine this new moment of inertia knowing the old moment of inertia plus the mass times this distance squared. So the parallel axis theorem is very important. It makes it a lot simpler to find the new moment of inertia, or whatever values you have, you can plug in and find either the new or the old moment of inertia. Okay, so now I will be reading question 19. The two discs, so this is part of a broader question, but for now I'm just going to read question 19 and then I'll refer back to the broader question. So the two discs are now shifted so that the axis of rotation goes through a point on the edge of the disc. The rotational inertia of the two-disc system is now. So in this problem, there's two discs, and they are rotating, and so the second disc is at rest and suspended above the first disc, as shown. There's no contact, and then what happens is the second disc is dropped on top of the first disc, and then they start rotating together at a final angular velocity. So that's what's happening. So basically, in this problem, we can easily solve it, question 19 specifically, using the parallel axis theorem. Because what's happening in this problem is it says the two discs are now shifted, so the axis of rotation goes through a point on the edge of the disc, so basically like this. And we already know the moment of inertia here, because we solved it in earlier ones, and so we can find the new moment of inertia here. Okay, so now I'm going to solve question 19. So I'm just going to write my little formula up here. I new is equal to I old plus md squared. Okay, so first what I need to do is find the old, or the initial moment of inertia when it's just rotating around its center of mass. So in this problem, they say, not in question 19 specifically, but the whole overview for this problem, they say that the rotational inertia of the disk is mr squared over 2. But since, so that's the moment of inertia they give us, but since there are two disks, because they're spinning at the same time, because one is dropped on top of the other, like I said, it's going to be 2mr squared over 2. So they give us mr squared over 2, but since it's two disks rotating, it's 2mr squared over 2. So we can cross these 2's out and just get mr squared. Okay, so we know what's I old. Okay, and then now we can plug everything in. So the new moment of inertia is equal to mr squared plus, and then the mass, since we have two disks rotating, the mass is going to be 2m, and then d squared, it's just going to be the radius that it's moved, because that's all they give us, so r squared. And so if we solve that, we get 3mr squared, and I knew. So the correct answer to this problem is B, because that's what we get, 3mr squared. So in conclusion, this problem shows important concepts of the parallel axis theorem, and how if we have the old moment of inertia and we know the distance and the mass, we can find the new moment of inertia, and that's very important for solving lots of problems like that.